Students, in this video, I am going to explain examples of SP3 hybridization. So, SP3 hybridization example, first one is methane. Methane means CH4. So, in CH4, central atom is carbon. Carbon atomic number is 6 and the configuration is 1s2, 2s2, 2p2. 1s means this is first level, 2 2, so this is second level. Second level, s orbital contains 2 electrons and p orbital contains 2 electrons. So carbon is combined with 4 hydrogens, so that means carbon should have 4 unpaired electrons, but it have only 2 unpaired electrons, so we have to excite carbon. So on excitation, so electron configuration will be 1s2, 2s1, 2p3. So 2s1 means like this and 2p3 will be like this. So now it contains 4 unpaired electrons. So these four orbitals combine together to form SP3 hybridization. So hydrogen atomic number is 1. So configuration is 1s1. That means it contains only 1 electron in its s sublevel. So these 4 orbitals, 1 s orbital and 3 pure p orbitals combine together to form sp3 hybridization. sp3 hybridization means 3 plus 1. So we will get 4 hybrid orbitals. So in carbon, we will get 4 hybrid orbitals. Carbon 1, 2, 3 and 4. 4 hybrid orbitals. Each orbital contains 1 electron. So 1, 1, 1, 1. With these sp3 hybrid orbitals, all these 4 are sp3 hybrid orbitals. With these sp3 hybrid orbitals, the pure orbital of hydrogen having 1 unpaired electron overlaps. We will get hydrogen s orbital is like this with 1 electron. This is another hydrogen s orbital with 1 electron. This is another hydrogen s orbital with 1 electron. This one is another hydrogen s orbital with 1 electron. So hydrogen, 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 hydrogen. The shape of the molecule will be like this. The shape of the molecule is tetrahedral. The shape of the molecule is tetrahedral, and the bond angle is 109 degrees 28 minutes. So this is the best example for sp3 hybridization, or simplest example for sp3 hybridization. Another sp3 hybridization examples are NH3 and H2O, ammonia and water molecules. So NH3, ammonia. So in NH3 molecule, central atom is nitrogen. Nitrogen atomic number is 7. Configuration 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So 1s means this is first level, 2, 2. So this is second level. So outermost level contains 2 electrons in s sublevel and 3 electrons in p level. So nitrogen combines with 3 hydrogens means nitrogen should have 3 unpaired electrons. So already in its ground state, it contains 3 unpaired electrons. So no excitation required. So it undergoes sp3 hybridization. Again, I am telling, in hybridization, only orbitals will enter but not electrons. So these orbitals, s orbital and 3p orbitals combine and undergoes sp3 hybridization. So hydrogen atomic number is 1, configuration is 1s1. It contains one unpaired electron in its s orbital. So hybridization occurs in nitrogen atom. So nitrogen hybridization, sp3 hybridization. So 1, 2, 3, 4. Out of these 4 hybrid orbitals, one orbital contains lone pair. That means 2 electrons, and other 3 orbitals contains one unpaired electron each. With these 3 unpaired sp3 hybridized orbitals, pure orbital of hydrogen, 1s pure orbital of hydrogen combines to form NH3 molecule. So 3 hydrogen atoms. So hydrogen, hydrogen, hydrogen. This is orbital containing one lone pair. So according to hybridization, the shape of the molecule should be tetrahedral. Shape of the molecule should be tetrahedral and the bond angle should be 109 degrees 28 minutes. But according to valency shell electron pair repulsion theory, according to valency shell electron pair repulsion theory, due to the presence of lone pair and bond pair repulsions. So the general structure or diagrammatic representation can be like this: NH3 with one lone pair and 3 hydrogens. So due to the presence of lone pair and bond pair repulsions, the bond angle changes from 109 degrees 28 minutes to 107 degrees, and the shape changes from tetrahedral to pyramidal. So in NH3, nitrogen undergoes sp3 hybridization, but the shape changes from tetrahedral to pyramidal due to lone pair bond pair repulsion. Lone pair bond pair repulsion. The shape changes from tetrahedral to pyramidal and the bond angle changes from 109 degrees 28 minutes to 107 degrees. Another example for sp3 hybridization is H2O molecule. So in H2O molecule, central atom is oxygen. Another example is H2O molecule. In H2O molecule, central atom is oxygen. Oxygen atomic number is 8. So we can write 1s2, 2s2, 2p4. 1s2, 2s2, 2p4 means this is first level. 2 means second level. So in second level, it contains 2 electrons in S subshell and 4 electrons, 1, 2, 3, 4. 4 electrons in P subshell. Okay. Next, oxygen combines with 2 hydrogens. So oxygen should have at least 2 unpaired electrons. So in its electronic configuration, it have 2 unpaired electrons. So there is no need of excitation of electrons. So it undergoes sp3 hybridization. Again, I am saying in hybridization only orbitals will enter but not electrons. So oxygen undergoes sp3 hybridization to form 4 sp3 hybrid orbitals. Out of these 4 sp3 hybridized orbitals, 2 orbitals contains lone pair of electrons. So 2 orbital contains lone pair of electrons. Another 2 orbital contains unpaired electron. With these unpaired electrons, 2 s orbitals of 2 hydrogen atoms with 1 electron combine to form H2O molecule. Originally or generally or according to hybridization, the shape of the molecule should be tetrahedral and the bond angle should be 109 degrees 28 minutes. Generally, we can write the structure of H2O as oxygen, hydrogen, hydrogen, hydrogen with 2 lone pairs like this. So these 2 are lone pairs, these 2 are bond pairs. According to Whisper theory, in H2O molecule, there are lone pair repulsions and lone pair bond pair repulsions. So the lone pair repulsions are more, that means magnitude is very high when compared with the lone pair bond pair repulsions. So in H2O molecule we have lone pair repulsions and lone pair bond pair repulsions. Due to these two types of repulsions, the shape of the molecule changes from tetrahedral to angular or bent structure. And the bond angle changes from 109 degrees 28 minutes to 104 degrees 30 seconds. So sp3 hybridization can be explained with 3 examples. And the first one is methane CH4, and second one is ammonia, and the third one is water molecule. So with these 3 examples we can explain the shapes and hybridization in molecules like CH4, NH3 and H2O.